Let's look at chapter 5 on solving nonlinear systems, but now we're going to be looking when we have rational solutions with radicals. We're going to look at absolute value systems and also complex solutions as an answer, like if x was 7i, or we could have a y value, have an imaginary part to it. So the first one, a nonlinear system with a rational solution with that square root symbol. So this one's a little bit different because this one has 3xy. We haven't done one with 3xy or just an xy combined with it. But we're still doing the same thing where we want to try to eliminate one, or in this case, we can actually eliminate two of our variables. If I were to multiply this bottom one by -1, I'm going to end up with my top remains unchanged. So x squared plus 3xy plus y squared equals 22. But then now my bottom is a negative x squared plus xy minus y squared would equal a -6. Still will add to eliminate, but this eliminates my x squareds and my y squareds, and all I'm left with is 4xy equals 16. Solve this, I could divide by 4 on each side, and then I'll have xy equals 4, so y equals 4 over x. So we only have an equation, we don't have an answer yet for y, but we can use this. Let's substitute this 4 over x into one of our equations, and I'm just going to use this bottom one that I'm going to substitute in. So I have x squared minus xy, but we know again our y is 4 over x, plus 4 over x squared equals 6. And so we have x squared minus x times 4 over x leaves just the 4. The x's go to a useful form of 1. 4 squared over x squared becomes 16 all over x squared, and that still equals 6. We could multiply both sides by x squared to clear that fraction, because now when I multiply these together, again, I'm going to multiply this into each term. Now I end up with x to the 4th minus 4x squared. This and this go to a useful form of 1, so all I have left is 16. That was the whole intent of multiplying by x squared, equals 6x squared. Well, I have the makings of a quadratic, so let's subtract 6x squared from both sides to set it equal to 0. So now I have x to the 4th minus, this one's going to be 10x squared plus 16 equals 0. So now we have a degree 4, a quartic polynomial that we need to solve for x. So we worked on this before. We could use that a substitution where I say, well, I'm going to let a represent x squared. So now rewriting this, I have a squared minus 10a plus 16 equals 0. So I've turned my quartic into a quadratic, and I can solve. So this, I'm trying to think of two numbers that multiply to get 16, but add up to be a -10. Well, that could be -2 and -8. And so now I just have a minus 2, and then a minus 8 equals 0. But remember, a was really x squared, so I have x squared minus 2, x squared minus 8 equals 0. So therefore, x has to be equal to 2, or I'm sorry, x squared has to be equal to 2, and x squared has to be equal to 8. And so x is going to be plus or minus square root of 2, and then x is going to be plus or minus square root of 8, which is the same. Square root of 8 we could simplify to 4 times 2 under the radical. Square root of 4 is 2, so this becomes 2 root 2. So these are our possible x coordinates. So let's start to build off to the side here what our final answer is going to be. So I know I'm going to have x equaling root 2, x equaling a negative root 2, x equaling a positive 2 root 2, and also x equaling a negative 2 root 2. Now I need to find the corresponding y's for each of these. I'll put this off to the side. So to find those corresponding y's, we're going to go back to this. Y equals 4x. And so if we're looking at this first one here, when x is root 2, my y is going to be 4 over square root of 2. Rationalize the denominator. Becomes 4 root 2 over 2. Those simplify to just be 2, so I have 2 root 2. So this y coordinate, when x is square root of 2, my y is 2 root 2. And I have to do that for each of them. So now going down to the next row, 4 over negative square root of 2. Same thing, I'm going to multiply. I can just do it as square root of 2 over 2. And so this becomes 4 root 2 all over a negative 2. And so this becomes negative 2 root 2. So when x is a negative square root of 2, my y is negative 2 root 2. Next row, 4 over 2 root 2. Again, I'm going to multiply to rationalize the denominator. So I have 4 root 2 over 4. Those go to a useful form of 1, so I'm left with a square root of 2. And then the last one, 4 over negative 2 root 2. Rationalize that. I'll end up with 4 root 2 all over a negative 4. So this is negative square root of 2. So that right there, I'll have 4 final answers, 4 coordinates. If x is square root of 2, y is 2 root 2, and so on. And those pairs have to go together. All right, let's look at another one. So now if we're working with absolute value, so x squared plus y squared equals 16, I could do some substitution here, and I could rewrite this. I could say, well, the absolute value of x is going to be 4 minus y, just moving things around. Now, I'm going to put that expression in here, and it doesn't matter that it was absolute value because I'm going to square it anyway. It's going to be positive. And so I have 4 minus y squared plus y squared equals 16. 4 minus y squared, this is 2 binomials, 4 minus y times 4 minus y plus y squared equals 16. So I have to FOIL, so this becomes 16 minus 8y plus y squared plus this additional y squared equals 16. Combining like terms, if I subtract 16 from both sides, I end up with 0. And I could combine these, so 2y squareds minus 8y equals 0. Let's do a little factoring. Let's factor out 2, and so all I'm left is y squared minus 4y equals 0. If I were to divide by 2 on both sides, 0 divided by 2 is still 0, but on the left, all I have is y squared minus 4y. Factor again, I could factor out y, so this becomes y minus 4 equals 0. So the only way to make this happen is if y is equal to 0 or y is equal to a positive 4. So we're halfway there. Now we still have to find x that goes with these pairs. All right, I'm going to use the first one, x squared plus y squared equals 16. So if I were to look when y is equal to 0, I'm going to have x squared plus 0 squared equals 16. So x squared will be equal to 16. Then x is going to be plus minus 4. Okay, so let's start to build our final answer on this one. So when x is equal to a positive 4, y has to be 0. And when x is equal to a negative 4, we also have a y equaling 0. But now let's try it when y is equal to 4, we have x squared plus 4 squared equals 16. So x squared plus 16 equals 16. We're to subtract 16 from both sides. We end up with x squared equals 0. So x has to be 0. So the last piece to our final answer, when x is 0, y is equal to 4. So we'd have those three coordinates for our final answer on this one. Now let's look at non-real complex solutions. So x squared plus y squared equals 5, 4x squared plus 3y squared equals 11. I'm going to try to eliminate, and so I'm going to multiply this top. Let's go by -3. We'll eliminate the y first. So now we have 3x squared minus 3y squared equals a -15. Bottom one remains unchanged. 4x squared plus 3y squared equals 11. Add to eliminate, the y's eliminate, and this actually should have been a -3x squared. And so we have -3x squared plus 4x squared would be a positive x squared equals now -4. We were to undo the squaring by using square roots. Undo the squaring brings in plus minus, and the square root of -4 using complex solutions is 2i. So x is going to be equal to 2i, plus or minus 2i. Now we have to take that and find the y values. And to find the y, I'm just going to use this top one, x squared plus y squared equals 5. So let's start out when x equals a positive 2i. Let's tackle that first. So we'd have 2i squared plus y squared equals 5. Well, 2i squared, it's a product, and so that 2 applies to both terms. So this is 2 squared, I squared, plus y squared equals 5. That I squared, remember, I squared is equal to -1. So this is 4 times -1 plus y squared equals 5. So -4 plus y squared is equal to 5. Add 4 to each side. Y squared would equal 9. So y is going to be plus or minus 3. So let's start to build our final answer on this. So when x is equal to 2i, our y is going to be 3, but also when x is 2i, we can have a y output of -3. Let's do the next one. When y is equal to a -2i, because we had two solutions here, positive 2i and a -2i. Or I'm sorry, when x is equal to -2i. And so we'll have -2i squared plus y squared equals 5. And so this is a -2 squared I squared plus y squared is equal to 5. This becomes a 4 times -1 plus y squared is equal to 5. -4 plus y squared is equal to 5. Add 4 to each side. Y squared will equal 9. And so y again is plus minus 3. But that brings in two additional solutions here. Because when our x is a -2i, we end up with a positive 3. But also when x is a -2i, we can have a -3. So we have 4 possible solutions for this one. And we can have an I in an X value and or an I in a Y value. Okay, so there's 3 additional examples on solving systems, rational solutions, absolute value equations, and complex solutions.